Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 19 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1415. The kth lexicographical string of all happy strings of length n. Okay, so let's read the problem statement first. A happy string is a string that consists of only of letters of the set A, B, and C. Okay, and s of I, it should not be equal to s of I plus 1 for all values of I from 1 to s dot length minus 1. Okay, string is 1 indexed. Okay, so for example, strings ABC. Okay, here AC. Okay, after A we have B, and after B we have C. Here after A we have C. Here we have B, and here if you see after A we have B, here C, then after C we have B. Okay, so here these are all happy strings, right? But here if you see these strings, so after A we have one more A. Okay, so this character at this index is matching with the character at this index. Okay, right? Here B and here this A is matching with this A, right? Here this B and this B are matching, right? So they are not happy strings, right? So s of I, it should not be equal to s of I plus 1. Okay, the character at index I, it should not be equal to character at I plus 1 index, right? If this is the case, then they are not happy strings, right? Given two integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. That simply means in the dictionary order, right? We have to return the kth string of this list or return an empty string if there are less than k happy strings of length n. Okay, so now let's understand the problem statement with an example here. N is equal to 1. Okay, and we can use A, B, and C. Okay, so first time n is 1. Okay, so we have to make the strings of length 1. So first A will come, then B will come, then C will come, right? That's it. And at 3, so at 3 we have C, so C is going to my output. Done. Okay, and here again n is 1, so we have to form a strings of length 1, right? And we have ABC. Okay, we have to use these characters only. So first time A, then B, then C, but here k is 4, and here the total length number of strings that I have, happy strings that I have, is 3, but k is 4, right? So there is nothing, so I am returning empty string here. Okay, that is my output. Now see this example number 3. N is equal to 3 and k is equal to 9. Okay, so we can use A, B, C. Okay, so now in the dictionary, how I'm going to sort them. Okay, ABC, we have to use ABC, and we have to form the strings of length 3 only, right? So first here let's do the one thing here, A, B, and C. Okay, so here first time I will start from here. Okay, so let's say I'm using A. Okay, so if I'm using A, so initially my there is empty string. Okay, there is nothing, right? So initially now I will have A. Okay, if I'm using A. Okay, and then this is my string A, B, C, right? Okay, now again I have to start from the initial index here only. Okay, so here first time my I is at this position. Okay, and I'm using this A. Okay, so now again I'm starting from here. So here next time I can't use this A, right? Because a character at I indexes should not match with the character at I plus 1 index. So next time I can use B here, right? So here I form this AB. Okay, from this A, B, C. All right, this is done. So again I'm going to start from here, beginning index. Okay, so here I can use this A, right? I can use this A for the first time, right? Because the previous character is B, it's not A, so I can use A here again. So now here I will get ABA. Okay, from this ABC. Okay, done. So this is one, this is one, right? ABA. So this is going to be my first string of length 3. Okay, which is happy. All right, so this is one happy string. Okay, so now after that we have to go back. Okay, we have to go back here. All right, so now if once we go back, because after that after ABA we don't want to add anything, right? Then our string length will be become 4, right? So I will go back. Now here instead of uh, this A, okay, here I'm using A, so instead of this A, if I use this B, but I can't use this B, right? Here previous character is B, and here I can't use B again. So here next option is ABC, right? So I can use ABC, I can form ABC from my string, which is ABC. Okay, from this string I form ABC. Okay, so here you see after ABA we have ABC. Done. Okay, then again we have to go back. Okay, so this is 2. Okay, first is ABA, here in white color. First is ABA, then next is ABC. Okay, now again I'm going to do backtrack. Okay, again I'm doing backtracking. So after AB, so here I have checked with A, I have checked with C. Okay, and there is no other possibility, so I'm going back here. Okay, going back here. So now here in this A, okay, this is A, right? So in this A, in this path, what I was using, I was using B, right? In this path I was using B. Okay, this arrow I was using B. Okay, after A. Now instead of B, there is one possibility now. I can't use A because then it will be continuous character, right? Same character continuous, right? So I can't I have already checked with the B. Okay, so now I have option to use C. Okay, so let's say I have used this AC. Now again one is pending from this ABC. Okay, so here this path I am following C. Okay, I'm using C. Okay, so now again I'm starting from here. So A I can use here at this, right? A I can use, right? So here in this path, let's suppose I use A, then what I will get, I will get A C A. Okay, A C A, A C A. So this is going to be my third. Okay, in my dictionary this is coming, right? A C A, done. Okay, ACA done from my string ABC. Okay, then we have to go back because we have already found the string of length 3, right? Now we go back. After this we can't add any character, right? Okay, so otherwise it will become a length of 4. Okay, and we don't need length 4, we need only length 3. Okay, done. So now here we use A. Okay, so now let's suppose if I use B here, I can use B, right? Then this is C, then this is B, we are good, right? So this is also one happy string, ACB, right? So this is one happy string. Okay, if I use B. Okay, so see here, ACB, done. Now I have to go back, again backtrack. So now here AC I have checked with A, I checked with B, I can't use C, then there are two consecutive characters same, right? I can't use that. All right, so this is done. Okay, so here there are no other options. Again I'm going to do backtrack. Okay, so after A I have checked with B, I have checked with C, I can't check with A, right? So again I have to do backtrack. Okay, so now I do the backtracking here. Now instead of A in the starting itself, if I use B, okay, if I use B, then this is my original string ABC. Okay, and my this is my new string. Okay, I'm forming this B, only B right now. Okay, and again I have to start from here. Okay, then here again we have to form, right? BAB, BAC, BCA, BCB. Then from C we have to check CAB, CAC, CBA, CBC. Okay, so you have to just draw similar tree. Okay, so this is nothing but my backtracking tree. Okay, so this is the same code that I'm going to write now. Okay, but I hope that you guys are clear with the tree diagram. So I have shown you the complete path if I follow A first. Okay, then same way you have to draw for B. Okay, this is your homework, and same way you have to draw for C. Okay, so you will get all these strings in lexicographic order. Okay, so here k is equal to 9, right? So here if you see in the explanation, he is giving 1 2 3 4 5 6 7 8 9. Okay, this should be my output, and he is giving 10 11 12, right? So you can do one thing. Okay, for simplicity you can stop here. Whenever I will what I will do, I will create one list of strings. Okay, and when my list of strings size is becoming equal to 9, I will stop. Okay, then I will simply return that. Then why do I need to check for this? No need na, I just need this. Okay, so this is for early exit if you want. Okay, and constant size is very small, I think. Then if you don't write that logic also, that will also work, right? But if you want early exit, okay, so you can do that as well. Okay, here. Okay, this is one more thing. Okay, now let's write the code. So very easy. So from last 3-4 days I think we are just solving backtracking questions only, right? So you can use the same code. Okay, right. So here first of all we have to maintain the count. Okay, so let's keep track of the count. So when my count becomes equal to that k value, then we will stop now. Then why don't we need to check further? Okay, so private int count is equal to 0. Okay, so this is globally I take for this class solution. Okay, and here just take one result string globally as well. Okay, string result is equal to, it's empty right now. All right, so now here in the main method just call this backtrack. Okay, and here just pass n k, and now new string builder. Okay, new string builder. Okay, we have to form the strings of size 3, right? So with the help of string builder, we can easily append or delete the character, right? So that's the purpose of this. And then after string builder, just here I'm going to add the last character. So initially it is empty, so there is nothing. Okay, so that's it. Okay, no character is empty, it's empty. All right, and from here I am just going to return result. Okay, so definitely in my backtrack method I will update the result. Okay, I will use this backtrack to update the result. Okay, so now let's see how I'm going to do that. Okay, so here let's define this backtrack now. Private void backtrack. All right, and here just int n, int k, and here just write string builder sb, and here char the last char. Okay, here I'm just going to add the last char, whatever last char I have. Okay, so here one base condition. Okay, so whenever my string builder length, okay, whenever my string builder length becomes equal to n, then that simply means that we have found first or one string. Okay, and we have to add that in our dictionary, right? So count plus plus. Okay, and now here just one base condition. Okay, if count is equal to k. Okay, so instead of adding all the strings in the result, okay, in the result, okay, I am not creating a array list. Okay, I'm not creating list, so I'm not going to add those all these in one list of strings. Okay, so instead of that I'm just making the count, just checking the count. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8, and when my count is becoming 9, I will just return this result. Okay, I will just store this result. Okay, so if count is equal to k, in that case only update my result. Okay, so result was empty initially, so in the result I will update to sb dot to string. Okay, so I'm just updating my result. Okay, done. And here this is base condition. Okay, we have to return every time. Okay, why? Because after that we have to do backtrack now, because after that the length will be become more, right? 4, 5. Okay, so we have to stop until 3. Okay, for this particular example, because my n is equal to 3. Okay, so we are returning here when my length becomes n. Okay, this is one base condition, and here we have to just use the characters abc only, right? This is given in the promise statement, so we have to iterate over all those characters only. So character new char. Okay, char array. In char array what we have, I have a, I have b, and I have c. Okay, these are the characters that I have. Okay, so I have to use these characters only, right? And now here I will just check if the character is not equal to last char. Okay, so in that case only we have to execute some things inside this. Okay, only in that case I'm just going to update my string builder. Okay, in the string builder I'm just appending the character. Okay, and then after appending this we have to do backtrack. Okay, we have to check other possibilities by using this. Okay, backtrack. So n, k, and sb. Okay, string builder, and this time this character is going to be my last character. Okay, then once we check all the possibilities with this, then we have to delete this character, right? So this is a simple backtrack code, right? Delete char at here sb dot length -1. Okay, so this is a simple backtracking code. And for early exit, okay, so if my result is not empty, then simply means that we have already executed this step. Okay, so if result is not empty, okay, if my result is not empty, then in that case you have to simply return. Okay, that's it. Okay, now let's run the code and see if there any code issue. We'll try to fix that. Okay, so there are some issues. Let's see. So this should be small enough. Let's run it. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you guys in the next video. Thank you. Bye bye.